Perfect. Well, hi again, everyone. Thank you so much for joining us today for the second session of SEB North America's public engagement series with the Nature Record. My name is Bernie Traversari, and I am the Managing Director of SEB North America. And I'll spend a few minutes today just introducing our session, going through a little bit of what SEB&A is, what the Nature Record is, and what our public engagement series is all about. Giving a few quick instructions as to how today is going to work, and then I'll pass it on to our speakers. So, first of all, for those of you that are unaware of SEB&A or SEB North America, we are a professional society dedicated to the advancement of the science and practice of conserving Earth's biological diversity. This means essentially that we provide support and mentorship to everyone and anyone engaged in conservation in North America. And we do that through a variety of different ways. We provide professional development opportunities. We host a number of research and publication journals through our global society. And we also host a biannual meeting, the next iteration of which will take place this summer. So we do a lot to support the conservation community, and we engage in a number of collaborations in order to do so. One of those big collaborations this year is with the Nature Record. And the role of SEB&A as a part of this collaboration is really to promote the work of the Nature Record, to promote the assessment, and to provide a forum for feedback for the assessment itself. So for the next few weeks, we'll be hosting a number of sessions like today to offer that platform for feedback and allow our members and non-members to engage with the authors of the assessment. So this is really exciting, and we really appreciate the Nature Record's partnership in this endeavor and for allowing us to take part in this. Okay, so the last little bit from me is just a couple of housekeeping items for how today's going to work. First of all, if you are interested in having closed captions on your screen, I suggest you click on the live transcript option at the bottom of your screen. We will be recording this session and posting it on our website, but unfortunately, transcripts are not always easily saved. So I suggest you turn them on your end in order to have those available. Next up, if you want to ask any questions during today's presentations, feel free to use the chat function. A staff member from the Nature Record will always be looking at the chat and going through questions so that they know to ask questions of their speakers if needed. And then in addition to that, if you just want to react to the information being provided to you, we encourage you to use the reactions button at the bottom of your screen as well. This could be used for questions, but also if you just find something that's interesting, please react in the moment. It's always a fun and engaging way to participate in our session. Okay, now in addition to that, the way that today's going to work, we're going to have a couple of presentations on 4 chapters of the assessment, followed by breakout rooms where attendees will be able to interact with the authors of each chapter and provide feedback. Breakout rooms will be available up until the end of our meeting, and we'll be providing a 10-minute notice so that folks can switch between rooms as needed. So if you're interested in providing feedback for each of the chapters, we encourage you to stay until the end and to attend each of the breakout rooms. Okay, that's it for me. Phil, I'll pass it on to you so you can introduce today's speakers.
Okay, I think I'm live. Is this working?
It is.
Okay. First, thank you all for being here. We really, really appreciate you taking time out of your busy schedule to be here with us. We look forward to your comments. And you'll hear this from a number of us. Your comments and thoughts and perspectives really do matter to us. Your input will be incorporated. It all gets kind of summarized. It goes to the authors for their consideration as they move forward in revising the draft. So thank you. We could not do this without your input, and we really want this effort to reflect your perspectives. So thanks. My job initially is to just kind of give you some background really quickly, high level background of the overall effort, and then turn it over to our panel of authors who are here today. And that will be followed by some breakout rooms, and then we'll wrap things up. Before I go further, I really want to acknowledge our staff. Um, Athena in particular has been really instrumental in building this partnership with SCB. And so thank you, Bernie and SCB, for everything you're doing to support us. And Tessa Francis, our deputy director, Leslie Wynn, and Courtney Deloach Hill have all been critical, very critical in everything that we've done. So I want to acknowledge them and thank them. And I'm just want to, start with like a reflection that those of us who study nature or spend a lot of time outside and interacting with nature, and even if we're walking around a city, we notice patterns. And we also know that lately, a lot of these patterns are really shifting. I mean, this year's is my own yard. Like, I don't know, flowers are definitely there earlier than they used to be. The frogs are definitely there earlier than they used to be. Pollinators that used to be abundant are seemingly harder to find. I'm seeing wetlands disappear, forests change, and coastlines that are getting reshaped. And they're not abstract changes. Like these are happening in places where we work and places where we call home. And so we know that something is going on. And we also know that nature isn't just scenery. Nature is something that supports our health and our food, our economies, and our cultures in very real ways. Nature shapes us. And I think what's interesting in the genesis of our work is that despite decades of research and monitoring, we really lack a clear shared picture of how nature is changing and what those changes mean for people across the US. And that's really the purpose of the nature record, to bring together what we know about our lands, waters, and wildlife and how they're changing and what those changes mean for our choices ahead. Because if nature shapes us, then the decisions we make today will shape what comes next. The nature record itself is really two things. One we're going to talk about today, which is this assessment. The second part of it is diverse products that help amplify the assessment and ensure that the assessment and the science has impact in the real world. This whole effort began in 2022 as a federal effort. Um, about a year after it started in 2023, there was a bunch of scoping and initial drafting. In 2025, with the change of administration and priorities, we stopped being a federal effort and became this independent effort called the Nature Record. So right now we're in a 2026 where we have a period of peer review and public comment. And then we are anticipating an online release of the final assessment this coming fall. And that'll be followed by a print release published by MIT Press. I want to emphasize that everything we've done is really built on a lot of early development and scoping. So we started in 2023 with a Federal Register request for information where we got 3,000 comments basically telling us what this effort should look like, what we should cover, what it should be. We included in that, as part of that early development, lots of listening sessions in different sectors in our space. So from forestry and timber industry to fishing to coastal zone users, outdoor recreation users, builders, and so on and so forth. Everybody who's like engaged in this space. We also had many tribal and Alaska Native consultations and Native Hawaiian engagement sessions, and lots of just general listening sessions. Ultimately, we heard from thousands of people from across the country, from hundreds of different organizations. All that early stuff led to really three fundamental questions that guide the work that we're doing and you're going to hear about today. The first is really what's happening, and that's kind of the focus of today. So, what are the status and trends and future projections of marine, terrestrial, and freshwater ecosystems? How are drivers of ecosystem change, changing? And what are human connections to nature, which is the subject of a later webinar. And then we explore why does this matter? And so the second question really focuses on how changes in nature manifest themselves in climate mitigation and adaptation, culture, the economy, human health, and risk resilience and safety. And finally, we ask, what can we do about it? Are there bright spots out there, success stories that we can learn from and that can be amplified and expanded? Are there opportunities for new and improved policies or practices? And this is all framed in the context of best practices in scientific assessment, climate change, and equity and environmental justice. All this put together generates a table of contents that looks like this, and you'll hear about many of these chapters today. We start with an overview and introduction, and then kind of a methodsy section and the frameworks. And then move right into the bright spots. And then today we'll hear a lot about status and trends of freshwater, marine, and terrestrial ecosystems, as well as drivers of change. And then the rest of the assessment focuses on the consequences of these changes and opportunities for changing policy and practice. Our audience for the assessment is really broad, I would say. We're focused on policymakers, not just environmental policymakers, but all policymakers, whether they're dealing with health or transportation, as well as, of course, the environment, and at all levels, federal, state, tribal, and local. We're interested in reaching and connecting to practitioners and land water managers, NGOs and advocates, business, philanthropy, educators, K through 12, undergraduate, graduate, journalists, and the general public. So a pretty broad audience. And that is my 5-minute overview of kind of the big picture of the project itself. And now what I'd like to do, let me stop my screen sharing, is transition to each of the chapters. And we're going to start with the terrestrial chapter. The terrestrial chapter really highlights some of the key findings across terrestrial ecosystems. This chapter is led by a great team headed up by Sharon Collins from the University of Arizona. So I'm going to turn it over to Sharon now. And I think I'm not sharing, so you should be good to go. Yeah. Okay.
Thank you so much, Phil. Can you see my slides? Okay, great. I'm thrilled to be here. I'm thrilled to be part of this effort, and thank you all for coming today and joining. What we're going to do today is kind of give you a teaser of several of the chapters that are reporting on status, trends, and future projections of ecosystems in the U.S. So I really encourage you to take a look at the assessment, to take a look at this chapter and provide feedback. We want to know what we got right, what we missed, and how we can improve this chapter. So this chapter is focused on terrestrial ecosystems of the U.S. I want to thank my amazing author team. We just had a terrific group of people come together to put this together in a relatively short period of time. So their names are all on the cover page of the chapter if you would like to know who was involved in this product. So our overarching question for this chapter is, what is the current status of terrestrial ecosystems and species? So we start out looking at where are terrestrial ecosystems. They account for about 93%, excuse me, of the area of the contiguous U.S. And about 13% of that area is protected in some form, either as a national or state or local park, conservation easement, and so on. We talk a lot in the first part of the chapter about land use and land cover change, so LULC. because that's the primary driver that has reduced habitat area for many species, causing declines or extinctions. Land use and land cover change also influences other drivers of species declines, including climate change, invasive species, disturbance regimes, disease emergence, and pollutants. So despite the conversion and degradation of terrestrial ecosystems, there's a long history, which we feature in this chapter, of conservation and restoration of these lands, and especially with a focus on working landscapes. There is an opportunity for humans and nature to both thrive in these landscapes. So I'll start with our draft key message 8.1. I'll go through our 3 key messages in this presentation. So our draft key message 8.1 is that land use, land cover change, and other disturbances, including those I mentioned, such as disease, pollutants, invasive species, and so on, have degraded ecosystems and have reduced biodiversity. This figure on the right is featured in our chapter, and this is showing land use and land cover change in 2 distinct areas of the United States. Southern California, showing Palm Springs on the left, and the changes in land use from 1985 to 2021. What you see here is the red areas of these 2 maps are developed land. The brown areas are cropland, and then the green areas are 2 forms of native vegetation. What you can see right away from this figure on the left is that from 1985 to 2021, there was an increase in the amount of developed land, some of that coming from grass and shrub or tree cover, other parcels coming from conversion of cropland to developed land. So this is showing the urban expansion of Palm Springs. On the right are national forests in Idaho, central Idaho. And again, from 1985 to 2021, what you see is a slight reduction in the amount of tree cover in these areas, especially if you looked sort of in the center left of this figure. That's primarily in this particular place due to increased catastrophic wildfire that reduced the amount of living forest tree cover to shrub or grassland areas that are then hopefully undergoing regeneration. Associated with this draft key message on land use and land cover change are risk of species extinctions for both plants and animals. So this figure that I'm showing you on the right shows the conservation status of plants and animals in the United States. The top set of bars is for plants, and the bottom set of bars is for animals. The warmer colors in these figures are showing species or species groups that are at risk. They're either possibly extinct, critically imperiled, or vulnerable, and this comes from NatureServe. And the cooler colors, the blues, are showing those species or species groups that are apparently secure or secure based on the data that we currently have. So one thing I want to point out over here on the right as well is the estimated number of species and then the percent of species that are thought to be at risk. The last thing I'll point out in terms of orienting you to the figure is these vertical dotted lines show the best estimate of the percent of species that are at risk for that group. So there's a lot to absorb here. What I want to point out first is if you look at the plants, cacti, about 48% of cacti species in the United States are thought to be at risk. And I think this is primarily due to land use and land cover change, but also collection of these species or harvest of these species for personal use. The lower figure shows animals across the US. And for all animals, that very top bar, it's showing about 40% of all animals are at some risk of extinction or risk of extinction. One thing that is especially noteworthy here, and I've underlined in red, all of the freshwater species. So freshwater snails, mussels, crayfish, and so on. I'm guessing Mary is going to talk more about this in her discussion of the freshwater chapter, but I just want to point out that where we see the highest percentage of species of animal species at risk are in freshwater ecosystems. As you go further down the figure, you can see bees. About 37% of bee species are thought to be at risk, beetles, about 35%, and so on. The very bottom bar is birds, at about 12% of bird species thought to be at risk. So this is a summary overall of plants and animals in the US thought to be at risk of extinction. Our second draft key message is that despite all of these changes in land use and land cover and increase in invasive species and diseases and so forth, effective ecosystem conservation and restoration actions can promote biodiversity and strengthen resilience of these ecosystems. So this figure is showing a series of conservation actions that are in place on the left under panel A. So the series of concentric circles that you see at the top left of the figure, and then conservation actions on the right that need to be taken as determined by the IUCN, the International Union for the Conservation of Nature, to reduce extinction risk. So the height of these bars is showing the number of species for which these actions have been taken on the left side of the graph. So the green, the dark green here, are monitoring and planning efforts. So for example, 1.1 is species recovery plans. And you see that about somewhere slightly over 1,000 species in the US have species recovery plans. So that's a type of conservation action that's in place. Land and water protection and management. Those are the orange wedges in this figure. And you can see quite a few species, over 3,000 species, actually over 4,000 species have land and water protection or management actions that are in place. So again, there's a lot to absorb in this figure, but I want you to just have a sense of what data we're including in our assessment. On the right-hand side, it's a similar set of concentric circles and wedges that are depicting those actions that need to be taken in order to reduce extinction risk for these species. Moving on to our third draft key message, this is that human-dominated landscapes, such as agricultural areas or managed forests or urban green spaces, can provide benefits to nature and people if they are structured and managed properly. And so this picture on the right is an example of cultural burning, where many indigenous and local knowledge holders are using burning practices to increase biodiversity for nature and also increase access and availability of certain materials that are important culturally in these areas. There are many co-benefits of these working landscapes, and this is just an example of a figure showing an agricultural area that has riparian woodlands that are enhancing water quality and reducing soil erosion. There are some remnant forest patches that are providing habitat for birds and bats that can prey upon the crop pests. There are diversified crop systems, and then there are wildflowers. In this case, it might be prairie strips that are attracting pollinators and overall improving crop yields. So these working landscapes can benefit, again, people and nature if they're structured and managed appropriately to provide those kind of benefits for nature as well as people. At the end of the chapter, we identify several emerging issues that came up as we were gathering data for the assessment, synthesizing the information available for the assessment. And so I'll just briefly go over these. These require more attention, more engagement, more understanding. So quickly, nature as a valuable asset to business operations. There is a lot of discussion now about assessing the value of nature, and that might influence land use and land cover change patterns. The use of AI and machine learning for measuring ecosystem status and being able to provide extensive real-time information on these ecosystems. The critical importance of indigenous and local knowledge for conservation and restoration. The siting of renewable energy installations, and this is a really important one to balance both the needs of conservation and renewable energy actions. the importance of climate change in driving adaptive solutions in conservation and restoration. And finally, the importance of assessing the effectiveness of nature-based solutions. So these are often being proposed and implemented, and it's really important that we understand how effective those are at both conserving biodiversity or restoring biodiversity and providing benefit to people. Thank you so much for your attention. I look forward to our breakout sessions and to your comments on the assessment. Please get involved. We need to hear from you, and it will make this chapter much better. Thanks so much.
Thank you, Sharon. That was great. Such a broad breadth of stuff covered in a very succinct period of time. So thank you. And as Sharon said, we look forward to talking in the breakout groups. And you can see the assessment itself and all the details at naturerecord.org. It's now my pleasure to turn over to Mary Power from UC Berkeley, and Mary will be representing her team that discussed inland water ecosystems across the United States. Off to you, Mary.
Thank you, Phil, and thank you all for participating in this. Thanks to the audience for coming, and thank you for all the various efforts you're making to engage with these issues. And I'm also, like Sharon, I'm very grateful to the wonderful team of authors that I worked with. I learned so much from them, and they've worked all over the United States and its territories, and it was just a wonderful learning experience. So thanks to them very much. We called it inland waters because we do treasure a few of our great salty inland waters, like the Great Salt Lake and Mono Lake. But what we're really talking about are the springs and wetlands and streams and rivers and ponds and lakes that we all love, but also are vitally connected with. And I think it's not a surprise to any of you that they are in crisis. They're very vulnerable, and this is going to get worse with climate change unless we take steps. But the bright news here, the happy news, is that we have good science that has been done by generations, and these ecosystems themselves are just incredibly resilient. The species have dealt with drought and deluge over their evolution. They are incredibly resilient. If we just give them a little bit of living space and living time, they'll repair themselves and we'll be the beneficiaries, especially as climate continues to change. So I want to spend time talking about landscape connections of these systems because we can't forget Sharon's topic, the terrestrial ecosystem. That's the way that we as citizens and we as humanity will really control the quantity and quality of our inland waters in the future. So it's a nested series of scales of landscape connections for our inland waters. Of course, we're all embedded in the global hydrologic cycle with precipitation hitting the land, snow or rain, and then sometimes flowing directly into surface waters, but more often hitting the land surface. And if you look in the lower left, you'll see a little cartoon that's actually extremely important because our inland water chapter contains also groundwaters and aquifers. But this is something you might think of as Earth's living skin, the critical zone from the top of the vegetation canopy down to the bottom of the groundwater. And that's what receives precipitation. The plants use some and evapotranspire it back to the atmosphere, but a lot of it infiltrates soil or rock and then is stored, chemically transformed in good or bad ways, and then percolates down to run off through springs and streams to replenish our surface waters. And the reason this is so important, obviously, is not only that it's the major control on inland water quality and quantity, but also that this is our backyard. Every hill has one of these. Every stream is fed by one of these. It's something that you can work on at the scale of individuals or watershed communities or at larger scales over larger areas. But this is something that every citizen should take responsibility for and know and love and curate. So then these are also the surface waters, when they're established, want room in many cases to establish vast collections, archipelagos of lakes and streams and floodplains. And these are just critical for our migratory fishes and our migratory birds and a lot of the complex life histories that we would like to see represented in a future planet. So this the landscape connection, as Sharon emphasized. Inland waters in the US only cover 4% of our land area, but they contain a hugely disproportionate number of the native species and native animals and the endangered or vulnerable species. So we go on in the chapter about this, but it's obvious why they're so vulnerable. They're the low spots in the landscape that will collect pollution or stress, and also they're thin features often, so they're easy to engineer and divert and completely alter. But again, these species have dealt with change in the past, drastic change, and they can come back if we treat them with a little bit more care. Our first key message is simply dire. Inland water ecosystems are in crisis. They're overdrawn, they're polluted, they're fragmented by levees, dams, and landscape changes. Important small-scale source of fragmentation that adds up is pavement. Impermeable surfaces fragment that infiltration, transformation, and slow release cycle that water quality requires. And also our inland waters are suffering from extinctions of our native species and terrible invasions that are very destructive from non-native species. But there's a lot of good news, and all of these stresses in terms of measures that are being put into action and are working. The famous Ogallala aquifer that supports so much agriculture in the western Midwest here is shown in the figure, and this is the depth that the water table has been lowered relative to before it was tapped, down to 230, 240 feet in some cases. This is in 2015. It's worse now. But this will not sustain agriculture or even human communities very far into the future unless something changes. So key message two is also not fun. It's going to get worse with climate change unless we do something. So many things get worse with climate change. You can imagine evaporation, need for water for other uses other than sustaining nature. And here are some odd ones. It turns out that some of our most harmful cyanobacteria are the ones that thrive as waters warm. The nutritious, good algae that build fish and other aquatic consumers, they perish when the water gets too warm, but the cyanos that release microcystin into our water supplies and shut down Toledo's water supply for 3 days, those cyanos thrive in warmer water, unfortunately. We've got to do everything we can to keep the water renewing, unpolluted, and to try to address the warming issue. Okay, here's the happy news. It is just astonishing how much recovery we've had with small and large scale restorations. And one that's really impressive is here, where the Illinois River is near its confluence with the Mississippi, right in the St. Louis area. So this region has lost 90% of its floodplain. The Mississippi was leveed and dammed for navigation. The former beautiful flooded forests and flooded grasslands were drained and put into corn production and other agriculture. And you can read a marvelous history about this in Daniel Schneider's reference cited in our chapter. But the Nature Conservancy 20 years ago did a careful engineering release of water into what used to be cornfields on the left and turned it into a 6,000-acre lake and wet meadow floodplain. And that place, Emiquon, now is attracting hundreds of thousands of birds, tens of thousands of tourists, and it's bringing back the many tribes who had lived there for, it's thought, 600 generations. and they're coming back to bless the lands and to start harvesting and being present on lands that very much are getting back towards what their ancestors had lived with. So these are the conclusions and emerging issues that we want to ask you about. We really can do so much creative work. There are so many good ideas for abating pollution. We can reconnect, and some people have been reconnecting hydrologic flow paths, removing dams, very happy news there, pushing levees back or removing them. Sometimes an engineered artificial floodplain grows a lot more salmon, even though it's protecting Sacramento from Sacramento River floods. It's also behaving like a natural floodplain. So a lot of these restorations that give nature living room are also really good for protecting and managing our urban infrastructure. We can think carefully and try to make our surfaces more permeable so that water gets stored, often purified in contact with the soil and released. Just a little tweaking of when the flood peaks happen, when the low flows happen, how low the low flows are, a little adjustment can do a huge amount of good for native species that have adapted, say, here in the West to Mediterranean flow conditions. We have cases of good news on that. And it's surprising, non-natives are such a problem, but our chapter features a success story for just taking care of the ballast of ships coming into the Great Lakes. It's been extremely surprisingly effective in protecting our Great Lake species from introductions. Oh, here's the issues we need help with, scientific and citizen help. We put toxicants on the land, not only too many pollutants, but a lot of hormone disruptors and just plain toxins from drilling, fracking. These are in some sort of cocktail there, evolving under UV light or other chemical and physical environments. We don't know what they're doing. And that there's a lot of research that needs to know what's happening underground, and then how effective are the microbes and other organisms underground at taking this pollution and transforming it. How long must water be in contact? How far should it flow before it's of sufficient quality to release back to surface waters? What are the limiting bottlenecks in the life histories of our valued species that are in trouble? How much genetic diversity is there left? What can we do to help them recover? And then what are the seeds for recovery for what they're going to face in the future? So those are questions for you guys, all of you guys. And I look forward to chatting with you in the chat room about your ideas. Thank you.
Thank you, Mary. And thank you to all the authors of that chapter. And I know people will look forward to talking to you in the breakout rooms. And as with the other chapters, the complete contents of Mary's team's work is on our website at naturerecord.org. It's now my pleasure to turn it over to Sarah Lester from Florida State University to highlight her chapter on marine ecosystems. Off to you.
Great. Thank you, Phil. So as Phil mentioned, I'm a professor of biological science at Florida State University, and I'm the lead author of the marine ecosystem chapter, and I have an absolute dream team of co-authors, and I'm really excited to share some of the highlights from our chapter today. So the key question that we set out to answer in this chapter is, what are the status, trends, and future projections of marine ecosystems in the US? And just as some context, the United States has a really vast ocean territory covering roughly 3.4 million square nautical miles. And so to put that in context, the surface area of the US exclusive economic zone, so that's our territory that extends 200 nautical miles from US shores, is 1.5 times the landmass of all 50 states and territories. And so this large area hosts marine ecosystems characterized by really diverse environmental conditions and rich biodiversity, and includes coastal wetlands and salt marshes, seagrass beds, kelp forests, warm and cold water coral reefs, and other important ecosystems. And importantly, we know less about US marine ecosystems than terrestrial and freshwater ecosystems just because research in the oceans is more costly and logistically difficult, particularly in the deep sea and open ocean areas that are far from shore. And so as a result of these challenges, our knowledge tends to be biased towards shallow habitats and species, and also species that are harvested in fisheries and protected species like marine mammals and sea turtles. And so population status is really only well known for a small proportion of US marine species. So the first key message of this chapter focuses on how marine life and ecosystems in the US have been highly altered. And specifically, marine ecosystems and species in the US have declined dramatically compared to a century ago, with overharvesting and habitat degradation causing the largest declines in many areas. So this figure from our chapter shows the change in the extent of key habitats relative to long-term historical estimates on the left-hand side and over recent decades on the right-hand side. And all 5 habitats for which we have historical data now cover only a fraction of their historical range and have continued to decline over recent decades. These habitats have declined largely as a result of harvest activity, coastal development, and poor water quality. Losses have been particularly widespread in coastal areas, notably wetlands, estuaries, and coral reefs. So for example, the Florida Reef, which is the 3rd longest barrier reef in the world, has lost up to 90% coral cover in some locations. But it's not entirely bad news. 2 habitats, seagrass and mangroves, show some recent increases, but unfortunately we lack long-term baselines for these habitats. And it's not only habitats that have been impacted, many species in the US have also dramatically declined. For example, many species of whales and other marine mammals, sea turtles, seabirds, and finfish species have been driven to low population numbers by harvest, pollution, altered water quality, and invasive species. Furthermore, many ecosystems and species continue to decline as the growing threat of climate change amplifies some of these other pressures. So climate change can affect marine ecosystems through a wide range of effects, including marine heat waves, sea level rise, melting sea ice, intensifying storms, and ocean acidification. And this figure shows the results of different climate change vulnerability assessments that were conducted by NOAA, the National Oceanic and Atmospheric Administration, for key species in different ocean regions. And these assessments show that the majority of populations that were examined are moderately, highly, or very highly vulnerable to potential climate effects in the coming decades, particularly along the Atlantic coast, where some of the effects of climate change have been most dramatic. Continued degradation and loss of marine ecosystems and species are expected in the coming decades based on current trends, although exact changes can be hard to predict. Future conditions could include expansion of some ecosystems and increases of some species. So for example, climate change appears to be resulting in the expansion of mangrove forests in some regions. In other cases, increases are expected of harmful species, including invasive species and diseases that impact marine species. So this photo shows the devastating impact that sea star wasting disease has had on sea star populations along the entire US West Coast. Our second key message examines the societal benefits of marine ecosystems, including important economic, human health, climate, and risk reduction benefits and cultural experiences. So over 129 million people, or almost 40% of the US population, lives in coastal counties, and marine ecosystems benefit people across the country by providing food, jobs, coastal protection, recreation, climate mitigation, and cultural and spiritual connections. Marine nature also plays a pivotal but often underappreciated role in supporting human health and well-being. So in particular, marine ecosystems produce oxygen, they filter polluted water, they provide healthy seafood, they support new medicines and biotechnology, and they benefit human well-being by serving as places to engage in recreation and fitness activities, and places to build positive emotional and spiritual connections with nature. But also the economic value of marine ecosystems makes them vital for coastal communities and the US economy. So for example, in 2022, commercial fisheries and the associated seafood industry in the US generated $183 billion in sales, $47 billion in income, and supported 1.6 million jobs. Ocean-based tourism and recreation also provide economic benefits, including activities that are closely connected to nature and marine wildlife, such as whale watching, coastal birding, snorkeling, and diving. Cultural experiences associated with marine and coastal ecosystems are not as easily assigned these economic values, and as a result, they are not always accounted for in management. Nevertheless, existing evidence suggests that these benefits, such as cultural identity and sense of place, can be very strong and important in coastal areas. Cultural experiences include teaching your children how to mend a fishing net, learning how to harvest seaweed to ensure it will regrow, or sharing in community meals that center around seafood. Now, many of the benefits that I just described depend on abundant populations of marine life and healthy ecosystems. And so the degradation of marine ecosystems and declines in marine species that I've also talked about have resulted in lost benefits. So as just a few examples, the loss of coastal wetland area in Florida increased the damages from Hurricane Irma, which hit the state in 2017 by an estimated $430 million. Harmful algal blooms have resulted in economic losses for the tourism industry in areas where they're impacted. And fisheries collapses because of overharvest or extreme environmental events have threatened the cultural identities and well-being of coastal communities. And further losses are likely to occur if marine ecosystems are not effectively managed, protected, and restored. But our third key message examines the tools that are available to us to protect and restore marine ecosystems in the US, given all the threats and declines that I've highlighted, and also the wide-ranging societal importance of these ecosystems. And so many efforts to conserve, protect, and restore marine ecosystems have been effective in the US. So laws that reduce nutrient and organic pollution have improved water quality in many estuaries and coastal regions around the US, fostering the recovery of species and habitats. And protected areas and species-specific legal protections have helped many depleted populations rebound, including seals, sea lions, whales, sea otters, and sea turtles. Unsustainable fishing has also declined because of strong management, and now federally managed fish stocks are generally healthy and experiencing sustainable fishing pressure. So in this graph, stock status is shown in orange. Values above 1 indicate healthy fish populations, and fishing pressure is shown in green. Values less than 1 indicate sustainable fishing pressure. And these trajectories show that since the 1970s, positive changes in fish population status and fishing pressure coincide with improvements in fisheries management. And so as of 2023, only 18% of adequately assessed federally managed fish stocks were considered overfished, down from 46% in 1996. Habitat restoration and marine protected areas are other key tools that have been effective at improving the status of marine ecosystems in the US. And such efforts are increasing, but unfortunately often not fast enough to keep pace with losses. So for example, the US has nearly 1,000 marine protected areas that cover 26% of marine waters, but these do not contain a representative fraction of US marine biodiversity because they're concentrated in certain habitats and regions. Similarly, activities to restore key habitats have resulted in meaningful improvements in some cases. So the graph here shows the large areas of wetlands and mangroves that have been restored. But these areas that have been recovered still dwarf the habitat losses that we've already seen in many cases. So increased investment in conservation and restoration initiatives would help protect the benefits that US communities and economies depend on from these systems. So in conclusion, ocean ecosystems face growing pressures from climate change, ongoing human impacts, and some emerging threats, such as the possible threat of deep sea mining for rare minerals. And so as we look to the future, innovative approaches and new technologies have the potential to greatly expand the scale and resolution of data that we can collect about marine ecosystems and how these data can guide management. So for example, developments in genomics are revolutionizing the ability to identify and study marine species. Remote sensing techniques from drones to satellites are providing data at unprecedented scales. And by leveraging artificial intelligence tools, we have new abilities to efficiently and effectively analyze these data and inform management and conservation. And so hopefully this chapter helps to highlight some of the challenges that we face in protecting nature in the oceans, but also helps chart a path forward. And I'm really excited to get feedback from all of you in the breakout rooms. Thank you so much.
Thank you, Sarah. And so we've now covered marine, terrestrial, and freshwater ecosystems and their status and trends at a high level, obviously, of what these teams uncovered. What I'd like to do now is just turn it over to Danielle Ignace from the University of Minnesota and her co-partner, Maureen Kearney from Arizona State. And they're really going to talk about what's driving those changes at a big scale. And so off to you, I think, Danielle.
Oh, Danielle, I think you're muted.
I'm not hearing you.
There we go. How's that?
Okay, good. There it is.
Out of practice on webinar format. Thank you. Thank you so much, Phil. And it's really fantastic just to see the other chapters and how far they've come. And I'm really delighted to join all of you today and hear your feedback. And it's been a really a monumental and at times heroic effort to reach this point of a draft chapter. And so I really need to thank my co-lead, Maureen, and of course, our incredible team of authors. There's no way that this could be done alone. So it really does require such an amazing team with the breadth and the expertise and just really amazing conversations, not just with the author team, but with others involved in the assessment. And naturally, this is a huge topic that we've had to deal with in our chapter, and it seems impossible to fully summarize it all within this time frame. So I do welcome a lot of questions and appreciate the feedback when we have breakout sessions, and feel free to reach out to me after this. Oops. I'll get the hang of this by the end, I'm sure. Okay, so we have two really big questions for our chapter. One, what are the existing status and trends of the drivers of change affecting species and ecosystems in the US, as well as what are the future projections for the drivers of change to nature in the US. And we took a really broad approach, and in answering these two questions, we also felt it was really important to think about the long-term changes in nature, and that we wanted to take not an approach that since the beginning, but it practically felt that way because we had to really look back in time to see what has really been driving the changes in nature, because we know that these drivers of change have a history as long as Earth itself, and wanted to summarize that and at least acknowledge that before we get to some of the human drivers. So we know that we have this long history of nature being shaped and reshaped by non-human forces, but a lot, and the most extreme perhaps changes and drivers that we've seen are due to human drivers on the landscape. And so while we have ecological, geological, and evolutionary forces, we also have other forces that have interacted over millions of years to shape the distribution of life in North America. And so if we look at the current and the state of what we've seen, it's important to recognize that ecosystems have remained, that no ecosystems have remained static, and some fluctuated dramatically even over short timescales. And so that we can look back historically and know that we've had current and future state of the environment, ecosystems, and biodiversity in the US affected by cumulative and ongoing series of anthropogenic drivers since the arrival and subsequent expansion of European colonization and settlement. So I'd like to guide you through this figure here. We do have created a spiral representation of, if you will, of a timeline. And the colors correspond not only to changes or increases in the geographic expansion and intensity, but also to time. And so it's color coded, as you can see in the legend in the bottom right. So if we turn our attention to the interior of the spiral, and that's when we have this colonization. And we also have green kind of representing, I would say, more of this lush and beautiful landscape and colors. And that we also have, this represents a past where over millennia, indigenous peoples throughout the US and US territories have carried out place-based practices. And we know that resilient ecosystems have been linked to long-term indigenous stewardship and land management practices. And then with the onset of the European expansion of the Americas in the mid-1500s, the establishment of colonies was followed by the killing and forced removal of indigenous peoples. In addition to that, the transatlantic slave trade and the system of plantation slavery were also major drivers of environmental transformation and reshaping these landscapes through coerced labor, intensive resource extraction, and global commodity production. And if you continue to move outwards in the spiral and move ahead to events in history, such as the Industrial Revolution, of course, this marks an incredible time of rapid and extensive industrial growth and modern impacts of human activities on the climate system and biodiversity were not fully realized by many of us or most Americans until many decades after this really large event. However, if we move on decades forward again, that we do have some policies in place and efforts, environmental laws that have really had a strong influence on the environment, such as the Clean Air Act, Endangered Species Act, and Safe Drinking Act, just to name a few of these. So these are, so to get to, that was the background. So that is the background to our chapter. And we have 5 key messages. The first is that we have a complex network of direct and indirect drivers caused by human actions and value systems that affect nature on an ongoing basis. It's important to recognize the direct drivers, and some of the major ones that have been widely recognized include habitat loss, pollution, overharvesting, invasive species, and climate change. However, these do not act alone, and we also have human activities affecting nature through more complex indirect pathways based on underlying economic, social, or political considerations driving these direct impacts. And these can all affect ecosystems differently across space and time. And so I wanted to guide you back through this diagram as well. This is a representation of the causal pathways that are driving changes in nature. And if we begin on the right, the way to read this graph would be to start on the right where we have nature, and in that the metrics that we can observe and measure are driven in part by habitat loss and degradation. So if you keep moving to the left of that, which in turn is the result of actions that people are taking, such as land conversion, wetland drainage, and logging in the case of forested areas. And climate change is also driving habitat loss and degradation, but we haven't fully realized that in this figure. But continuing down the stream of this causal pathway, land conversion, et cetera, is happening because of economics. And this would include things like farmer financing and thinking about profit and policies such as the Farm Bill and other incentives. So all of that are facilitated by political considerations and ultimately by what societies value. So this really guides us back through what's the ultimate cause of these changes in nature. This really stems back through this pathway to what we value. And our second key message of that main drivers of change in nature correspond with trends in human population, expansion, migration, as well as research expansion. So urban and agricultural land uses have expanded and spread westward across the contiguous United States over the past 4 centuries, displacing forest, shrubland, and grassland. And to direct you to the figure here as well, this is one of many figures that we have for this section, this is definitely the largest section we have of our chapter to get all of the different drivers in there and how they could impact the ecosystems that we've already heard from. And this represents the spatial patterns in major land uses in the contiguous US. If we start at the top left in 1630, and we kind of wind our way down to the bottom right of the figure in 2020. As you can see by the legend and the different color codes, as we move through the different colors, just to point out a few of the big ones: forests in the bright green, pasture in yellow, cropland in dark orange, and urban in red. So we have definitely seen this population growth and westward migration in the late 19th and early 20th centuries that has driven massive agricultural expansion and forest resource extraction for fuel wood and timber. And these trends were closely followed by over-harvesting of US fisheries and dam building that fragmented river systems, and patterns that we've seen have begun to reverse in many ecosystems in the 21st century. Of course, we also discuss industrialization and technological development that led to growing fossil fuel extraction and mining impacts on ecosystems throughout the 20th century. As we are well aware, introductions of new or introduced species peaked in the 20th century, but their abundance and impact continue to grow on within our systems. I do want to highlight a positive. This one of the themes of our chapter is not only to perhaps paint this picture of drivers as all doom and gloom, but there are some positive outcomes that we really want to highlight as well. And one would be that regulations and the positive impacts that some of these environmental laws can have on the environment. This is a figure from this section showing the spatial patterns of total nitrogen and sulfur deposition from the time period of 2002 to 2017. So if we look at the top three panels, A, B, and C on the left is the total nitrogen in 2002, in the middle 2017, and on the far right, we have the trend for that time period. These are color coded so that we see if it's a bright yellow or green, we have a massive increase. And as well on the far right, if it's red, we've seen an increase, or if it's blue, we've seen this decrease. And a similar type of breakdown of the trend and the time frame. And really the main takeaways from this is that deposition of both nitrogen and sulfur have declined dramatically since 2002. And so this is a really positive outcome of how good regulations such as the Clean Air Act can benefit nature by reducing nutrients deposition. And but pollutants such as other nutrients and plastics, of course, still remain a problem within our systems. So our next key message are that drivers of change in nature rarely operate in isolation, and interactions among drivers are complex. So one of the challenges to interpreting and predicting how natural systems will respond to change is that drivers of change rarely occur in isolation. There has been research to look at individual drivers and observe how those impact our ecosystems. However, it's not simply an additive process, and it's not as simply straightforward as that. So this really complicates our ability to make future projections and predictions of what will happen. And of course, we know that because of these complex interactions, we can have different categories of how they will impact systems. So on the first kind of category, the drivers can be additive, of course. In this example, we can have oil extraction in combination with residential development that both destroy habitat and reduce populations in equal measure, and that these are additive and have this overall impact in a direction and magnitude equivalent to the size of the gray area in the image. And whereas if we were to look at one of these individually, we could make some direct connections to perhaps some conservation efforts that we could use to help support some species that are degraded by some of these activities. In the middle, we have that drivers can be antagonistic in that they may not be equal. They might have opposing or differential impacts. And so in this case, we could have siltation versus sea temperature rise. Both are detrimental to coral reef organisms. However, siltation could block some of that sunlight. And of course, that sunlight would be a driver that's increasing water temperature. So if we can block some of that, then we would have these antagonistic or opposing impacts. So that might not be so bad overall when we take into account those multiple drivers. And on the right, we have that drivers can be synergistic in that, in this case, if we have disease plus lead poisoning, this poisoning weakens waterfowl, reducing their ability to survive and deal with disease. And these can have these synergistic and highly interactive impacts that can overall feed into each other and lead to much greater impacts than if we looked at them individually. So I would say it's difficult, very difficult to predict complex interactions among these many drivers. And of course, these can change over space and time as well. And so this is a challenge that we need to deal with moving forward. Okay, so our next fourth key message for the chapter is that the future status of drivers of change in nature depends on human policies, decisions, and actions. And we have a few graphs from this section as well. Future drivers of change in nature are uncertain and can depend on these policies, but we took an approach that we felt it was important to develop and have an analysis of scenarios that take into account complex socioeconomic interactions and physical constraints. So in this figure on the right, this is one of several figures. We consider three different scenarios. SSP is shared socioeconomic pathways. So these describe future socioeconomic, geopolitical, and technological developments, greenhouse gas concentration pathways, and changes in other climate drivers that resulting energy imbalances in the climate system under various climate policy assumptions are also described. If we were to tease apart this graph, we show that the top panel is GDP, and as well as the changes in population growth in the bottom panel. So the SSP5 scenario assumes a world with rapid economic and population growth, energy-intensive lifestyles, and an abundant use of fossil fuels. SSP3 assumes a fragmented world with regional rivalries and weak global cooperation with accelerating population growth, slow economic growth, and limited technology transfer. SSP2, socioeconomic and technology developments continue on pathways similar to historical trends. So a lot to sum up here and kind of wrestle with, but overall, in our future projections, these future scenarios generally project an increase in population and economy activity, such as gross domestic product, a slowdown in future land use change, as well as an increase in climate change relative to historical changes. In that these future national scale policies will have really important implications on the status of drivers of changes in nature in the US. Our fifth and final key message emphasizes that strategies that focus on core human values can be effective at mitigating negative drivers of change and sustaining the future benefits of nature for all. And so with this, we rely on a more traditional, I guess, framework for what we see in terms of how we view ecosystem goods and services. So in this more traditional model, it's always been unidirectional in that we have received plenty of benefits from ecosystems. And this has often been divided into different services that benefit humans, including supporting, provisioning, regulating, and cultural services. And so, again, this is a unidirectional framework, and it's related more to an extractive framework. However, we are positing a new framework in which there is a multi-directional, a more reciprocal relationship with nature that doesn't just rely on that extraction and those benefits that we receive or humans receive from ecosystems, but that humans also provide services in a way that supports or enhance nature. And so what this means is that at the core, if we have this mindset and are tying back to those causal pathways, and that this all stems back to what we are valuing, then we can make decisions and in a way that can support, enhance all these different ecosystem goods and services that have previously been outlined. And that if we focus on the foundational ones, such as soil health, clean air, clean water, biodiversity, that we can in fact accomplish still receiving the benefits from all these ecosystem goods and services. But this does require that reciprocal relationship and a framework that where we support nature. There have been some good examples of this, I have to say, within this framework, and some newer examples, and I think a couple of them have already been mentioned. One would be the Klamath River, a very new outcome of dam removal, and then seeing in such rapid response the increase or the return of nature in showing how resilient it is in its return to improved enhanced levels. We also have seen, yet we can live with dams and still have salmon restoration like we've seen in the Pacific Northwest, including tribes like Coeur d'Alene in that region. And we can see also this in examples of regenerative farming. And of course, others have mentioned cultural burning that have, by indigenous communities, that we've seen such a revitalization, and that helps to have more resilient ecosystems in a sustainable model with benefits for all. So we have some emerging outcomes from this. Of course, new drivers of change in nature are emerging, many that mirror earlier forces, but manifest at different scales and intensity with the potential to rapidly transform ecosystems. Existing drivers of change are also continually co-evolving with the same transformational potential. For example, this would be accelerated energy and water demands that we've seen due to data centers and artificial intelligence. Novel governance approaches to co-management of natural systems are emerging. These have potential for significant changes to how nature and the drivers of change in nature will be managed in the future. So there's an increased understanding that when we have diversity of multi-level values and concepts, which is acknowledged in collective action, conservation initiatives are more likely to succeed. And so relational understanding of worldviews, human nature relationships, and value concepts can be more holistic, inclusive, and transformative for policymaking and decision-making. With that, I will just slightly over time, and I will stop there. And thank you.
Thanks, Danielle. Just a quick couple notes before I turn it over to Bernie, who will guide us into the breakouts, I think. Again, all the details of these chapters are at thenaturerecord.org. So please check them out. Also, I wanted to acknowledge there was a few comments about figures as we went through today. I just want to acknowledge briefly, we have a team at NC State. We call them our technical support unit, and they've been really helpful in taking some of the visions of the authors and turning them into graphics throughout. And so thanks to them, and thanks to the authors for really coming up with some unique ideas for the figures themselves. And finally, I wanted to note that there was a few comments in the chat really supporting Danielle's framing around reciprocity. And to the extent that that is something you want us to double down on, I encourage you to look at other chapters and find opportunities where that sort of framing might be usefully applied. And with that, I'm going to turn over to Bernie?